This lesson will involve showing you how to divide polynomials, and we're going to use two different methods to do this. So to begin with, I'm going to show you the long division process, which is really what you're already familiar with. It's just that it looks a little different since we're dividing algebraic expressions, but the process is the same as what you learned many years ago in the long division process. And then in the second half of this lesson, we're going to show you a new way to divide, which is going to be very helpful for a couple of sections from now when we start solving polynomial equations. We're going to use the synthetic division method. But to begin with, let's show you how to do long division, which is what you're going to do on problems 2 through 8 even. All right, so you remember back in the old days, to set up long division, we're dividing x plus 1 into the polynomial x cubed plus 4x squared plus x minus 6. Now, in the long division process, dividing by x plus 1 really means that I'm dividing by x. Okay, think of dividing by x into, we'll begin with this first term, x to the third. If I divide x into x to the third, that should be x squared. Now the x squared is going to be multiplied by both of these terms. Okay, so just to repeat that, I'm dividing initially by the first term of this binomial into the first term of this polynomial, but the result gets multiplied. Just think of the distributive property. So when I multiply x squared times x, I get x to the third, and when I multiply x squared times 1, I get, of course, x squared. Well, you remember a long time ago, after you multiply, then we're going to subtract, all right? And just be careful here, because really you're subtracting both of these terms. So this is a common mistake that people make. When I'm subtracting, I'm not only subtracting x to the third, which of course makes 0, but I'm also subtracting 1x squared from 4x squared. So 4 minus 1x squared is 3x squared. Okay, remember long division, we will bring this next term down, just the next term, and the process repeats. So I divide first term, x, into first term, 3x squared, and that's positive, so I'm going to put plus x into 3x squared is 3x. Okay, now 3x needs to be multiplied by both of these. 3x times x and 3x times 1. Okay, now we subtract, and be careful. You might want to use parentheses just to remind you that not only are you subtracting 3x squared, but you're really also subtracting 3x. So 1 minus 3x is negative 2x. Okay, bring down the next term and repeat. X goes into negative 2x, negative 2, and now you multiply. Negative 2 times x and negative 2 times 1. All right, and we're going to subtract. Be careful. Negative 2 plus 2x makes 0. Negative 6 minus negative 2. So remember, negative 6 plus 2 is negative 4. So my final answer here will be this x squared plus 3x minus 2, but we ended up with a remainder of negative 4. All right, that's the long division process, so we're just going to practice a few more of these. Still showing you that this is what you're going to do for 2 through 8 even. So let's set up dividing x minus 5 into this polynomial. Plus 13x plus 3. Okay, so dividing x, remember just dividing x, first term into first term, that would be 9x squared. Now 9x squared will be multiplied times each one of these. So 9x squared times x, and 9x squared times negative 5. All right, subtract. And that means subtracting both. So this makes 0, x cubed, or just 0. Negative 48 minus negative 45, that's really adding 45x squared. So that's negative 3x squared. Bring down the next term and repeat. X into negative 3x squared is negative 3x. And now multiply. Negative 3x times x. And negative 3x times negative 5 is positive 15x. Subtract. This makes 0. 13 minus 15 is negative 2x. Bring down the final term and repeat. X into negative 2x, negative 2, multiply. Negative 2 times x, negative 2 times negative 5, and subtract. 0x, 3 minus 10 is negative 7. So that ends up being our remainder, and we'll just show it like that. So you can notice a pattern. If I'm dividing into a cubic, and we're always dividing binomials into these polynomials, notice how my answer will be 1 degree less. And that was true over here. I divided into a cubic. My answer was quadratic, 1 degree less. Okay, I think I just got one more. This is the way it's actually presented in your book. So just wanted to show you a little different form, and I also wanted to show you something to be really careful about. And so let's set this up. X minus 2 being divided into x cubed. Do you notice that there is no quadratic term? It jumped from degree 3 all the way to exponent 1. When this happens, common mistake here, you got to be very careful. You're going to have to plug in, just for spacing purposes, you're going to have to plug in that missing term. Just make it 0x squared. That's very important. If you don't do that, you're going to not get the correct answer. Okay, so just pay attention. Do your exponents follow a pattern? And in this case, they don't. We're skipping the 2, exponent 2, so I filled it in. Okay, and now the process is just like we showed you earlier. I'm dividing x into x cubed. That's x squared. Now multiply x squared times both. And subtract. So, of course, that becomes 0, x cubed. And 0 minus negative 2, well, that's the same thing as adding 2x squared. Bring down the next term. Divide. X into 2x squared is positive 2x. Now multiply. 2x times x. 2x times negative 2. Subtract. Negative 9 minus negative 4. Well, that's like adding 4x, so that's going to be negative 5x. And bring down the minus 5. X goes into negative 5x, negative 5 times, negative 5 times x, negative 5 times negative 2, subtract. And of course the x's cancel, negative plus makes 0. Negative 5 minus 10 is negative 15. And so that's our remainder. Now, it just so happened that the 3 examples that I picked all have a remainder. You don't always have a remainder, so I don't want you to think that you'll always have a remainder. Okay, well that takes care of long division. So let's, let me go ahead and show you what does it mean to be a factor. You're going to do two of these problems, numbers 10 and 12 look just like this. The question is this binomial a factor of this trinomial? Well, we're going to do long division, and the goal is if I can do long division and end up with a remainder of 0, then the answer to this question is yes, x plus 1 is a factor. If I end up with not a remainder of 0, then the answer will be no, it's not a factor. Okay, so let's see what we get when we divide. All right, so just repeat the long division process, x into x cubed, x squared. So that would be x cubed plus x squared. Subtract. And 4 minus 1 is 3, x squared. Bring down the next term. Repeat the process. X goes into 3x squared 3x times. Multiply 3x times both. 3x times x, 3x times 1. Subtract. 0, 1 minus 3 is negative 2x. Now bring down the final term. Repeat the process. X goes into negative 2x, negative 2 times. Negative 2x minus 2. And I subtract, and you can probably tell that we are not going to get a remainder of 0. We're actually going to have a remainder of negative 4, negative 6 plus 2. So the answer to the question, well, they're saying determine whether this binomial is a factor. Well, since I got a remainder, the answer would be no. If, I know it doesn't work out this way, but I'll just change the problem just so you can see it. If I did go through all this process, I know it doesn't match, and I ended up with a remainder of 0, then I would say the answer is yes, it is a factor. Okay, so you will do 2 of those on your homework. Do the division and see if you end up with a remainder. If you do, then the binomial is not a factor of this polynomial. Okay, well, let me show you a new type of division that's going to be very handy for what we're going to do in sections 6.5 and 6.6. This is called synthetic division. Okay, synthetic division works like this. We're going to create, I call this the house. Okay, it's like a half box. In this half box, and this is crucial because so many people miss it right here. Without going into a lot of variable explanation, let me just see if I can just show it this way. I'm trying to make this video fairly short. Synthetic division involves dividing by a binomial that we call x minus a. Okay, what we're putting in this half box is literally a. All right, so without going into a definition, I just want to see if you can follow what's about to happen. Okay, so if I compare this red x minus a to what I'm dividing in this actual problem in blue, x plus 2, then that means a in the blue case must have been negative 2, because subtracting negative 2 would create plus 2. Okay, so this is another one of those cases, and it seems like we have it come up quite a bit, where you really have to think opposite of what you're looking at in this problem. When you look at what you're dividing by, it says plus 2, but remember, a should be the number that goes in this little half box, and in this case, a must be negative 2. So you're thinking opposite. Look at the binomial that you're dividing by And whatever that is, whatever the number is, you're putting the opposite number in the what I call the house. Okay, to the right of the house, I'm going to write the coefficients and the constant of what I'm dividing into. So 6, negative 4, positive 14, negative 8. Notice I'm not using any variables in synthetic division, just the coefficients and the constant. I'm also being very careful, just like we talked about earlier, that I'm not jumping over or skipping over any exponents. Okay, so I started with 3, then I went down to 2, then to 1, and then the constant, so we're good. All right, I'm going to intentionally leave a space for some numbers, and I'm going to draw a line. So eventually there will be numbers, not here, but there will be numbers in between number and line. Okay, so we're about to begin the synthetic division process. It always begins by bringing this first number, not the one in the house, but the first number, in this case 6, I'm going to bring it down below the line. Okay, just remember that numbers below the line multiply times the number in the house. All right, so I brought the number down, and now I'm going to multiply 6 times negative 2, and my result goes to the next column. So you can always remember that this space will always exist. There will never be a number in synthetic division underneath or between this first coefficient and the line. This will always be blank. All right. The great thing about synthetic division that is different from long division is we always add. We never subtract. Okay. So I multiplied, I got negative 12, and now I'm going to add these two together. Okay, now the process repeats. Negative 16 times negative 2 is positive 32. So the product just goes to the next column, and you add 32 plus 14. Okay, now numbers below the line, 46. Multiplies times the number in the house, 46 times negative 2, negative 92, add. Okay, now we're going to change our answer. Just like we did with long division, our answer was a polynomial. Okay, you see that? Well, these numbers represent the constant and the coefficients for a polynomial. Okay, so remember what we said earlier, when you divide, your answer should be 1 degree less than what you divided into. So it makes sense that my answer here should be quadratic. I divided into cubic, the result should be quadratic. All right, so let me show you how to interpret the answer given these numbers. This right column will always be your remainder. Moving to the left, this next number will always be a constant in our polynomial. Okay, and we're just moving up 1 degree as we move to the left. This number should be a linear coefficient. And this number should be a quadratic coefficient. You won't have to write this every time, I just want to show you. So here's my final answer. You don't just do the synthetic division process and stop. Our answer should be a polynomial, and so our answer is going to be this: 6x squared minus 16x plus 46 with the remainder of negative 100. Okay, and that is synthetic division. Okay, let's try another one. Again, you're going to be doing synthetic division in the problems 14 through 22 even. So let's set it up. I'm noticing what I'm dividing by. It says x plus 2, but remember that means in my house I'm going to put negative 2. Be very careful here. Okay, plus 2, putting the opposite. To the right, I'm going to write the coefficients and the constant, but I notice that I went from exponent 4 to exponent 2. So the cubic term is missing. So in place of that cubic term, I'm going to put a 0. Then I'm going to follow that up with -6, -27, leave a space, draw the line, synthetic division begins. Okay, bring down the first number, and then numbers below the line multiply. 1 times -2. And with synthetic division, you always add. 0 plus -2 is -2. Multiply -2 times -2. The product goes to the next column, and then you add. -2 times -2, add. Now, interpret the answer. Remember, this is the remainder. This is a constant. This is a linear coefficient. This is a quadratic coefficient. You know what? Instead of redoing this problem, and I apologize, I just noticed that, and this is easy to do, so you really have to be careful. I caught myself as I was writing the answer. You probably caught this already. We jumped over 3, but we also skipped from quadratic to constant. So I should have plugged a 0 in place of the linear term that's missing. So I apologize for that. Okay, now it's going to work out. Because I should have ended up with a cubic answer, and I noticed I had a quadratic answer, the answer should be 1 degree less. Okay, so let's bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. Okay, so you get the idea. Always start off by bringing down the number and numbers below the line, multiply, and then you add the columns together. So let's interpret the answer. This is remainder, constant, linear coefficient, quadratic coefficient, cubic coefficient. So my answer is going to be x to the third minus 2x squared minus 2x plus 4 with the remainder of -35. Okay, so I think I've got one more. Let's try this one. So right off the bat, I'm going to investigate. I'm going 3, 2, 1 constant. So we don't have to plug in any zeros. I'm dividing by x minus 1, which means I'm going to put +1 in the house. I'm going to put my coefficients and my constant. Leave a space, begin the process. Bring down the 1, multiply. 1 times 1 is 1, and then add. -2 plus 1 is -1. Multiply, -1 times 1, add. Multiply, -6 times 1, add. So here's our first case of a 0 remainder. Remember, this represents constant, quadratic coefficient, or linear coefficient, quadratic coefficient. So it does match up. I started off dividing into a cubic. My answer is going to be quadratic. And if there's no remainder, you don't have to put remainder 0. That's just our final answer. Okay, finally, the last set of problems are going to involve what we refer to as the remainder theorem. So in a nutshell, without going into a fancy definition of the remainder theorem, I just want to show you what this means. Use synthetic division and the remainder theorem to find P of A. Well, hopefully you remember from what we've done earlier, P of A just means, in this case, if A is 3, it's like finding P of 3. So in other words, let's replace all of the x's with 3, and see what we get. Okay, P of A is 3, so it's really like finding P of 3. Okay, 2 times 27, 3 to the third power, plus 4 times 9, okay? And I'm going to go ahead and multiply these together. And we'll just kind of simplify this a little bit at a time. 2 times 27 is 54, plus 36, minus 30, minus 9, and let's see what we get here. 54 plus 36 is 90. 90 minus 30 is 60. 60 minus 9 is 51. Okay. Well, here's the cool thing about the remainder theorem. If I use A as 3 in synthetic division, all right, notice I didn't need to change this to the opposite because they went ahead and told me what A is. Okay, it would be like this. It would be like our problems earlier, and we were asked to divide by x minus 3. And A, in this case, would be 3. So when they tell you what A is, you don't have to worry about changing it because A literally goes in the house. Okay, so let's divide, synthetic division, and let's write out our coefficients of this polynomial. 2, 4, negative 10, negative 9. I didn't skip any. 3, 2, 1, constant. Okay, leave a space. Now let's start the synthetic division process. Bring down the 2. 2 times 3 is 6. That's 10. Always add. 10 times 3 is 30. And 20. 20 times 3 is 60. Lo and behold, what do you think we get? We get the same result. So this is what I want you to show for these problems 26 through 32 even. I want you to find out what the value of the function is given A, and then I want you to prove that that's the right answer by using synthetic division. So if you don't get the right answer, then you know something's wrong in one of the cases. So these two numbers should match. All right, and that's an application of the remainder theorem. Okay, I hope that helps. Your assignment is on RenWeb, and it's also right there. So if you have trouble, send me an email, and I'll be glad to help you.